Everyone, this video is for the question 16 in assignment 4. This is an ERD question again, and for this ERD question, you should have 3 tables and 5 data records for each table, and the whole data model should be able to forward the engineer. I'm not going to read the business rules here. I actually have already created those 3 tables, so I'm going to explain some details here. So our first table is the employee table for the employee entity, and this is the entity supertype, and there is only one entity subtype in this question, which is this inspector table. So according to the business rules, we can only identify one entity subtype in this question. And there is another weak entity called dependent. So the existence of the dependent table, the dependent entity, depends on the existence of the employee table, the employee entity. So that's the reason why the dependent table has a composite primary key, dependent ID plus the employee ID. So I'm now going to show you the attributes and the data type for each table. So first is the employee table. So the employee ID is of course the primary key. The data type is int. Primary key not null, unsigned, because we don't need any negative number for an ID attribute. And since this is also a single attribute primary key, you can set it as auto increment. And the next one is this employee SSN. You could also use the int data type. And this UQ means unique, which this column flag is used for those non-prime attributes, but also needs unique values like the SSN in this case. Of course, this is every data record must have a unique value for employees SSN, but this is not a primary key attribute. And then our employees' first name, last name, street, city, state, zip code, phone number, email address, the employee's starting date and the end date, employee's title, the salary. The data type for employee salary is decimal 82, which means you could have 6 digits before the decimal point and 2 digits after the decimal point. And this employee is INSP, is the subtype discriminator attribute in the entity supertype. The value of this attribute will determine if a certain record, a certain entity instance in the employee entity is an inspector or not an inspector. So I use a Boolean data type for this attribute. So the value for a Boolean data type can only be true or false. So if the data value is true, which means for this data record, he or she is an inspector. If the data value is false, of course, that means for this data value, for this data record, he or she is not an inspector. So this is the entity supertype employee. And then we have this entity subtype inspector according to the business rules. So the primary key of any entity subtype must be the same as the primary key of its entity supertype, which means the primary key of the inspector table should also be employee ID. You cannot use primary key like primary attribute like inspector ID. So that's not correct in the specialization hierarchy. And there are also some unique attributes which only make sense for the entity subtype inspector. So the inspector's certificate date and their certificate renew date. Of course, the data type should be date. So okay. So here the primary key employee ID data type int, and column flag should include primary key not null onside, and you can also set it as auto increment. Since this employee ID later will also be the foreign key to maintain the one-to-one relationship between employee and inspector, so make sure the data type and the column flag you select for this employee ID in the inspector table are the same with what you set for the employee ID in the employee table. Okay, those are the attributes in the inspector table. I will explain those constraint later. And the last entity is dependent table, dependent entity. So this is a weak entity. Then the relationship between those two entities, those two tables later will be a strong relationship. It has two attributes as its primary key. The dependent ID, of course, and also the employee ID, because as I have already said, the existence of the entity dependent table depends on the existence of the employee table. So those two attributes then are both primary key attributes. Of course, they should both be not null onside, and please don't set them as auto increment here, because those two, of course, they are not single attribute primary key component. And other non-prime attributes include dependent SSN, first name, last name, street, city, state, zip code, phone number, email address, and this this is optional attribute. So so you can use different data type, but what you selected must make sense. So it's fine if you want to use different data type with what I'm using here, but it must make sense. Okay, so then we need to create two relationships, right? So the first relationship is a one-to-many relationship between employee and dependent. According to the business rule, if you go back to the business rule here, so all dependents must be associated with one and only one employee, and some employee will not have any dependent, and some of them may have many. So that's the reason. So the maximum and the minimum cardinality of employee is both 1. So one dependent must be associated with one and only one employee, while the minimum and maximum cardinalities of dependent is 0 and minute. So one employee may have many dependents. So this employee ID in the dependent table serves as both a foreign key and part of its primary key. So this is a foreign key. What we need to use is, again, this last. Place a relationship using existing column, and first click the employee ID in the dependent table, and then the employee ID in the employee table. And the relationship name could be has. One employee may have many dependents, and one dependent belongs to is associated with one and only one employee. So here both minimum and maximum cardinalities are 1, so we don't need to actually change anything here. And but here the minimum cardinality should be 0. You should see a circle here, not a vertical line. So what you need to make change is this relationship line. Double click it, or you can right click and select this edit relationship and go to the foreign key, and then set the entity dependent table as not mandatory. You see this this minimum cardinality here becomes 0. This also means dependent is optional in this relationship, right? So employee can exist without the existence of dependent, but employee is mandatory in this relationship because of the minimum cardinality here is 1. So this is a one-to-many relationship between employee and dependent. And the relationship between any entity supertype and entity subtype is always a one-to-one relationship, no matter how many entity subtypes we have in a certain specialization hierarchy. So this employee ID is both the primary key and also the foreign key for the one-to-one relationship between employee and inspector. So we need to first click the foreign key, the employee ID in the inspector table, and then the primary key, the employee ID in the employee table. So here, the minimum cardinality and maximum cardinality for employee are both 1, because I think this is fixed. So one inspector must be associated with one and only one entity instance data records in the employee entity in the employee table. But one employee may be one inspector. It cannot be a must here. Otherwise, those two entities, those two tables, actually present the same thing. You should combine them. You should not create a specialization hierarchy between them. So here should be always 0. The minimum cardinality should always be a 0. So one data records in the entity supertype may be also one data record in the entity subtype. So for any case, not only for this case. Okay. So then we need to change both the minimum and the maximum cardinality for inspector. What you need to do is also click the relationship line and go to the foreign key, and first set the here I think it's always better to call it classification, but the connect also work. So please change it first to 1 to 1, and then you can see the maximum connect here has been changed to 1, and then set the inspector as not mandatory. So as you can see now, here the minimum connect becomes 1, and the maximum connect becomes, oh sorry, the minimum connect becomes 0 and the maximum connect becomes 1. So you can say 1 employee, maybe also 1 inspector, but 1 inspector must be 1 and only 1 employee. And yeah, that's for those 3 tables. And I think according to the business rule, yeah, you should actually indicate disjoint overlapping and partial total completeness constraint, and also identify the subtype discriminator attribute using text box. So the subtype discriminator here is this employee is inspector, this attribute. So as I said, I set it as Boolean data type here. So later the data value I use must be either true or false. But from last semester's class, so some students had difficulties in setting the data type here as Boolean. So it's okay if you want to use like a tiny int and then use the data value 0 or 1, or you can also use like virtual, I don't know, so virtual 9, virtual 10, and the data value used later could also be true or false, or you can say yes or no. So that's okay if you cannot set a data type here as Boolean. So okay, so this employee is inspector or not is the subtype discriminator. Please use a text box to explain which attribute is the subtype discriminator here. And then for partial and total completeness constraint here, since we only have 1 entity subtype, then it must be a partial completeness. It cannot be a total full completeness, because if it is a total or full completeness, that means what? That means every entity instance, every data record in the entity supertype must appear in one of its entity subtype, and then we have only 1 entity subtype. In other words, every entity instance, every data record in the employee table must also appear in the inspect table. Then it makes no sense to create this specialization hierarchy. You should actually combine those 2 entities together, because as I said before, they actually means the same thing. So you shouldn't like create 2 entities here. So if you see later, not only in this case, but for all cases, if you only see 1, if you can only identify 1 entity subtype, it can only be a partial completeness constraint. It cannot be a full. Okay, this is for partial completeness. And for disjoint and overlapping constraints, so you can skip, you can omit this constraint here, because according to the business rules, we simply don't know if there is another, if 1 entity instance, if 1 data record in the entity supertype can appear in more than 1 of its entity subtype. So we don't have like enough information to determine the disjoint overlapping constraint. So for this constraint, you should actually omit it here. So please also explain those two constraints using a text box. So yeah, so that's all for the tables, relationships, and constraints. And unfortunately, according to the business rules requirement, you should also have 5 data records for each table. So I have already created option. So you can use what I'm using here, or you can make up data records by yourself. It's not a requirement that you must follow what I'm doing here. So for this is for the 5 data records in the employee table, employee ID, SSN, first name, last name, street, city, state, zip code, phone number, email address, and start date, end date, their title, and their salary. So yeah, it's decimal A2, so you could also like say it's this value. It's also correct. And as I said, if you have a true value here in this subtype discriminator, then later this record, this employee ID 1, must appear in the inspector table. So if you have a false here, for example, for the employee ID 2, then later this employee ID 2 does not need to appear in the inspector table. But since according to requirements, you should also have 5 data records in the inspector table, right? So yeah, you have to set all of them as true. So unless you want to like create, for example, 10 data records in the employee table, then you could, for example, have true, false, true, false, true, false, and then pick up those data records which have a true value in this column, and then add it into the inspector table. So, but if you only want to create 5 records in the employee table, please set all of them as true here for the subtype discriminator. Okay, so this is the data record for the employee table. Okay, then as I said, for the inspector table, since all those 5 data records in the employee table have a true value in the employee is inspector, so I have to put all of them also here. But those two are their unique attributes, only make sense for inspector, so you should use like you should use different like date value here. So employee ID 1, 2, 3, 4, 5, and their associated inspector certificate date and certificate renew date. Okay, so again, if you have like for example 10 records in the employee table and you set them as like true, false, true, false, true, false, true, false, and then the employee ID you have here should be, I think, 1, 3, 5, 7, 9, right? And again, so after you insert into all data records for any table, so please apply the changes here. And then the dependent table. So for the dependent ID, you should use 1, 2, 3, 4, 5. But for the employee ID, since some employee may not have any associate dependent, while some of them may have many associate dependent. So some employee ID, for example, employee 4 does not need to appear in the foreign key column, the employee ID column here, while this employee ID 2 appear twice. So because the minimum content here is 0 and the maximum content is a minute. So yeah, so this is employee ID information, and okay, 1, 2, 3, 4, 5, and employee ID, dependent SSN, their first name, last name, street, city, state. Yeah, also, so similar to project 1, what you insert into here must be consistent with the data type you set here. So here I have a char 2, and then later I can only use like 2 characters in the dependent state, and zip code, phone number, email address, and notes. Since this is optional attributes, you don't need to put anything there if you don't want. Okay, so that's all for the data record, and the last part is to make sure your ERD can be forward engineered. I will check this part. So first is to change the schema name to your FSU ID. Okay, so it works, and then save this as save it as assignment 4 MWB. Please save it as MWB. So please don't give me a PNG, because I cannot check the forward engineering process. I cannot check the data records if you just give me a PNG file. Okay, so save it as a model. And this is what you need to upload for question 16 here. The whole model, the MWB file. Okay, so that's all for this video, for this question 16. I saw some of you have already submitted your assignment 4. So because you only have 1 attempt, so if you want to recreate this MWB, this ERD, because I just posted this video, so you can email it to me directly, and I will grade that copy you emailed to me. Okay, so thank you.